Okay, so the notes for this section, we're going to be solving using elimination method, also known as linear combinations method. And the title is very important because it kind of directs you on how to start, right? We're going to end up combining the lines, right? And our goal is to get either the x or the y to eliminate, okay? So the title helps us. Step one, it says a setup. Make sure that they're all lined up and organized. What do I mean by that? X's on top of x's, y's on top of y's, equal on top of equal, number on top of number. But you know what? Let's do this. Everybody on your notes, let's write down rewrite in standard form. Standard form is a form that we learned and that we used in semester 1. You guys remember what standard form is? What is it? Ax plus by equals c, right? You want your x's and y's on your left side and your number by itself on the right side. And that's what it pretty much means to line up your x's on top of x's, y's on top of y's, equal on top of equal. So if you look at example 1 up here, they're both in standard form. They're both ready to go, right? They're lined up. X's on top of x's, y's on top of y, equal on top of equal, number on top of number, right? So that's step 1, to make sure that they're lined up. Sometimes they won't be lined up. Like, for example, if I wanted to use elimination method on number 2, right here, they're not lined up, right? They're not in standard form. So you'd have to move this 2y over here, add 17, move it over there, move this 2x over here, rewrite it in standard form. That's step 1 to make sure it's organized. Now, many times, especially on today's worksheet, today's homework, it's already done for you. It's already lined up. It's already in standard form, both of them. Okay? So step 2 is to think about the goal. We want to combine the lines to get a variable to cancel. All right, we want to combine the lines to get a variable to cancel. So when I say combine the lines, it's kind of like adding, right? So I have a x right here and an x right there. If I combine them, what do I get? 8x, right? Positive 5x, positive 3x, we get a positive 8x. If I combine the negative 6y with the positive 6y, they cancel out. Good morning. So right here, they cancel out. And that's what we want, right? Title, elimination method, we want something to eliminate. So the equal comes down, and we still need to combine the negative 32 with the positive 48. And what's the negative 32 and positive 48? Positive 16. And of course, we could use calculators, right? Excuse me. So again, the title is linear combinations. We're combining the lines. It's also known as elimination method because that's the goal. You want something to eliminate. You want either the x's to eliminate or the y's to eliminate. And right here, luckily, the 6y and the negative 6y, they eliminate. So what do we have now? We have 8x equals 16. That's a super easy one-step equation, right? So let's solve that one-step equation. It says 8 times x equals 16. All we're going to do is divide by 8, and x equals 2. I don't know about you guys, but that's pretty easy to me, right? And I know this might be the first time you're seeing it. You're like, what? What's going on? Again, well, that's all you do to get one answer, right? And what do you do when you already have one answer? You already know this from previous. You plug it in, right? So let's take that 2 and plug it into any equation we want, either the top or the bottom. I'll go for the bottom here. So my new bottom equation, 3x plus, I'm sorry. Instead of x, we're going to put parentheses, and we're plugging in that x value of 2. Plus 6y equals 48. So let's just solve this problem. 3 times 2 is 6. 6 plus 6y equals 48. Subtract the 6. Subtract the 6. Cancels. We have a new equation that reads 6y equals 42. Divide by 6. Divide by 6. Y equals 7. We have one answer, x equals 2. We have the other answer, y equals 7. Let's write it as an ordered pair. 2, 7. And that's our answer to system number 1 using elimination method, right? And again, if we just think about the title, right? What's it called? It's called linear combinations method. We're going to be combining the top line with the bottom line. It's also known as elimination method because our goal is to get either x to eliminate or y's to eliminate, okay? So sometimes it's ready to eliminate, like number 1, it's ready to eliminate, right? Number 2 is also ready to eliminate. So what I'm going to do right now is I'm going to pause. If you're at home watching this for the first time, pause it, try to do it, and then we'll go over it. But right now, you guys in class, I want you to help each other out, try to get through this problem. Let's see if we could get an answer, and then I'll explain it. Okay, so number 2, it's already ready to combine. It's lined up. X is on top of x's, y is on top of y's, equals on top of equals, and so on and so on. And not only that, when you do combine them, x's really do cancel out. So when I combine 2y plus 1 more y, that's a total of 3 y's equaling -6. So that's a simple one-step equation that we're going to solve by doing the opposite of multiplying by 3. And we'll get y equals -2. That is one answer. And whenever you have a y, or an x for that matter, whenever you have one answer and you need the other, all you do is plug it back in, and you can plug it into any original equation you'd like. So I'm going to go with the top one. The top one reads 7x plus 2y, but instead of y I put parentheses because I'm going to plug in the -2 for y because y equals -2 right in there. And we still have equals 10. So doing the math, I'll have a new equation that reads 7x minus 4, because 2 times -2 is -4, equals 10. And to get rid of the -4, I do the opposite, plus 4, plus 4. So I will end up with 7x equaling 14. Which brings us to our last step, to get rid of the multiplication of 7 in front of x by dividing by 7. X equals 2, that's 1. The answer, and we're done. So let's write it as an ordered pair. The ordered pair is 2 for x and -2 for y. Once again, if you were to have solved this using a different method, substitution, you'd still get the same answer. If you were to graph it, if you had graph paper and you graphed it, the two lines would intersect at that coordinate 2, -2. Okay, guys, so once again, the top 2 questions, the top 2 systems we've done, they've been ready to combine and cancel. But if I take a look at number 3 right here, are they lined up? Yes, they're in standard form. Are they ready to combine the lines in order to eliminate an x or a y? No. Right? Like, check it out. If I combine it, I'll get 6x. If I combine it, I'll get 36y. That's not good. It's 36. Right? So we don't want this situation. We don't want to combine the lines yet. Let me erase this. Okay, the whole goal of combining the lines is to get either the x's to eliminate or the y's to eliminate. So it says over here on our notes, step 2, multiply one or both equations by a value so that either an x or a y cancels out when you combine the lines. So we're going to have to modify maybe one or both equations. So the question is, what would you like to cancel out? The x's or the y's? The y's. Y's look easiest to cancel out. Now why the y's? Why not the x's? Because if you wanted to cancel out the x's, this would have to become a -4x for it to cancel out with a positive 4x. So you could, if you wanted to, choose to cancel out the x's and multiply the whole top equation by -2. That way it becomes -4x. That way when you combine it, they'll cancel out the x's. But obviously this one's a positive 18y, this one's a positive 18y. It's easy to get those 18y's to cancel. All you have to do is multiply one of those equations by what? A -1. So that bottom equation, it's up to you. What do you guys want to do, the bottom or the top? Bottom? Sure, why not? Let's multiply the bottom equation by -1. And I actually like to write the parentheses and write outside in front the -1. That way, if I want to go back and retrace my steps, I'll know that I multiplied by -1. So if I go -1 times 4x, what do I get? -4x. If I go -1 times positive 18y, we get a -18y. And -1 times -27, we get a positive 27. So that blue equation down there is the same thing as the bottom equation. I just modified it by changing all the signs, by multiplying everything by -1. Okay. Now the top equation I'm not going to mess with. I'm just going to rewrite it over here. 2x plus 18y equals -9. And if we take a look at that system right there, this new modified system, now it's ready to rock, right? Now we're able to combine the lines and the y's eliminate. Okay, so I combine the lines. What's 2 with the -4? That's a -2. And of course, we're talking about x's. The positive 8y eliminates with the negative 18y. The positive 18y and the negative 18y eliminate. The equal sign comes down. And -9 plus 27, that's positive 18. Correct? Yeah. So this new red equation is a simple one-step equation that we could all solve. So we're going to change that multiplication of -2 to a division of -2. And what you do to one side, you do to the other side. And we will get x equals -9. And that's one answer. And if we need another answer, all we need to do is plug it back into any original equation. I'm going to go with the top one. 2x plus 18y equals -9. Now the x value is -9. And let's do the math. 2 times -9, that's -18, plus 18y, I'm going to rewrite everything, equals -9. So to get rid of the -18, you add 18, good job. And what you do to one side, you must do to the other. So what we have left here is 18y equaling 9. A lot of people freak out right here because in order to get rid of that 18 in front of the y, you'd have to get rid of the multiplication of 18, right? So you have to divide by 18 and divide by 18, and that's okay. The 18s cancel. Y equals 9 over 18. You can't really do it, but you could reduce it, and it becomes 1/2 or 0.5. So our answer in ordered pair format is -9, comma 1/2 or 0.5. Now, there will be for sure next Friday, not this Friday, for sure next Friday, we're going to have some that have answers that are fractions, all right? Let's say you're weirded out right now with this fraction of 1/2. You could always plug it in and see if it works, right? If you plug in a -9 for x, 2 times -9 is -18. Let me just jot down -18 so I keep track of our values here. And then if I plug in 1/2 right here for the y, 18 times half, that's really a positive 9. Half of 18 is positive 9. So -18 plus 9, that really does give you a -9. So you've double checked the top one. Let's do the bottom. If I plug in -9 for x, that becomes -36. 4 times -9 is -36. And then 18 times y, which if y is half, 18 times half, again, is going to be 9. That'll be positive 9. And if you do this with the calculator, -36 plus 9, it really does give you -27. So even if you were taking the quiz and you feel weird about this answer, you could plug it in and work it out with the calculator, and you'll see that it really does work for both the top and the bottom equation of this system. Number 4. So again, you don't have to use elimination method. If you wanted to, you could get x by itself. You could go plus 3y, and you'll have x equals 3y plus 20. And you could substitute the 3y plus 20 into the other equation you haven't used. You could use substitution method if you wanted to, right? But I honestly, my preferred method is elimination method. The only time I'll choose substitution is if it's ready to substitute, kind of like on number 2, where it's ready to substitute, right? Y is already by itself, okay? Or instead of elimination method, if I had them both in y equals mx plus b, and I have graph paper, then I might choose graphing, right? If they're already ready to graph. But for the most part, elimination method for me is my favorite, and I think it's the quickest, the best way. So this last one, if I combine the lines, will something eliminate? No. Okay. What would I have to do in order for something to eliminate? Multiply what? The top equation or the bottom equation? Okay, multiply the bottom equation by what? What would we? It depends on what you want to cancel out. Do you want to cancel out the x's or do you want to cancel out the y's? It's up to you. Now, you might choose to cancel out the x's, your partner might choose to cancel out the y's, and it looks like you're doing something completely different, but you're both going to get to the right answer, of course, if you don't make mistakes. So it's up to you. Do you want to cancel out x's or y's? Y's? Okay. Like, if you wanted to cancel out x's, you'd have to multiply everything by -7. That way, your 7 and your -7 would cancel out. But since you guys said y's, I need to change this -3y into what? So it could cancel with the positive 15y. I need to change this to what? To a negative what? 15, right? In order to change this -3 to a -15, what am I going to multiply it by? By 5. So let's put a 5 outside of the parenthesis. And now let's distribute 5 times x, we get 5x. 5 times -3y, we get -15y. That's what we wanted, so we could cancel with the positive 15y. But don't forget to distribute to the answer over there on the right side. 5 times 20 is 100. So that blue equation right there is your new modified equation after multiplying everything by 5. Now, why do we multiply by 5? So that the y's will cancel. See, the top equation, I'm not going to mess with. 7x plus 15y equals 32. But now I could take a look at this new modified system and I could combine the lines. The y's cancel. 7 plus 5 is 12, and we're talking about x's. The equal sign comes down, and 100 plus 32 is 132. So if we were to divide by 12, you got the answer?
11.
What's the answer?
11, -3.
Okay, so you did get the answer 11 for x. How did you find the other answer?
I did substitution.
Substitution. To which equation, though? The top one or the bottom of the original?
The top one.
You did the top one? You like big numbers, huh? Yeah. That's okay. You could use the top one. I want to go with the bottom one because the numbers are a little bit smaller. So on the bottom, instead of x, I want to put 11 and then -3y equals 20. That's the bottom equation. But instead of x's, I put 11 right in there. So let's solve this thing. There is no need for the parentheses. So you could simply erase them because there's nothing to multiply it by, nothing to distribute. So to get rid of that 11, I'm going to subtract 11. What you do to one side, you do to the other, subtract 11. You're going to have a new equation that reads -3y equals 9. And the final step here would be to divide by -3, divide by -3, y equals -3. 11 comma -3. There you go. If you had time, plug it back in, double check. You could use a calculator. Now, on all of these, we only had to modify one equation. And some of them, like the first two, we didn't even have to modify anything. Number one, it was ready to cancel out the y's. Number two, it was ready to cancel out the x's. Let's take a look at the hardest type of system. And how about this? Everybody flip your paper over, copy this one down. Now, I say this is the hardest type because you have to actually modify both equations to get something to cancel, okay? So if you started combining the lines, that's pointless because the x's will not eliminate, the y's will not eliminate. You either need to cancel out the x's or the y's. So right here, we're going to have to modify one or both equations, and we're going to have to modify both. So what would you guys like to cancel? The x's or the y's? What would you like to eliminate? The y's? If you wanted to cancel out y's, this -6 would have to become negative something, and this has to be the same exact value but opposite. So it'd have to be positive, that same value. So you'd have to, I'll tell you right now, you'd have to convert this to a -42 and this to a +42, right? Now, wouldn't it be easier to cancel out x's?
Yeah.
They're a little bit smaller, right? I could change this +3x to a +12x. And I could change this -4x to a -12x. That way the +12 and the -12 cancel out. So there's many roads to the same place, right? You could take the long path, or you could think about it and take the shortcut. So let's put parentheses around both of them. And let's cancel out the x's. I need to multiply the top one by what? 4. Now if I do multiply it by 4, it becomes 12x. What else? Minus 24y equals 4 times 9, 36. The bottom one, I need to change that negative 4x to become a negative 12x. So what do I need to multiply it by? By 3. That way it becomes negative 12x, and then positive 21y, and then negative 48. And of course you could use a calculator. So the original system, it wasn't ready to eliminate. But after modifying both equations, now it is ready to eliminate. And like I said, this is as hard as it gets. When you have to modify both equations, it's not that bad, right? So the x's cancel out. Negative 24 plus 21, that's negative 3y. And the 36 take away 48, that is 12, negative 12. So it's a simple one-step equation. Let's divide by negative 3, divide by negative 3, y equals positive 4. You have one answer, you need the other. All you have to do is plug it in. I'm going to plug it into the top one. 3x minus 6 times 4 equals 9. So that's 3x minus 24 equals 9. You add 24. Add 24. 3x equals 33. So x equals 11. And your ordered pair answer is 11, 4. I apologize. This has been a really long lesson. Obviously, there's a lot to cover on this lesson. But hopefully now you're prepared for the worksheet. And of course, I'll upload a video on the worksheet later.